Alright, we're looking at 5.6 problem number 2. It's a two-parter that includes the same definite integral. We're just using different boundaries here. So let's start with the first one. They try to kind of explain a u substitution for you to use, but it's important that we start to see the u substitutions for ourselves. So one trick to look for with u substitutions when dealing with polynomials is to look inside of this term and to say, how much is my highest power of t compared to my highest power of t on the outside? So we have t to the 4 and t to the 3. Well, the derivative of t to the 4 is going to be some family of t to the 3. So that's going to tell us that we want to choose our u to include this t to the 4. And with u substitution, we always want to include any constants that we can in our u term. That way we can destroy them by taking the derivative. So if this is u, then du dt equals 4t to the 3, which likewise means that du equals 4t to the 3 dt. And then we want to get this to match that, so we need to divide the 4 over. Divide the 4. So we found that 1/4 du equals t to the 3 dt. Well, now this part, du fourths, we'll substitute in for t to the 3 dt. And our u substitution, we'll substitute in for the inner term here, 3 plus t to the 4. And we're going to leave it to the third power because we can deal with that using the reverse power rule. So we'll do our substitution now, and we'll find that what we have is 1/4, right, because 1/4 du equals this, u to the 3, because there's our u term to the 3, and then we're going to have du. And so this looks a lot better now. There's two ways to deal with the boundaries. Probably one of the easier ways, because these boundaries change when you do a u substitution. So it's probably best to take our u right here and plug in our lower and upper bound. So our lower bound is 0. 0 to the 4 plus 3 is 3. So our u boundary on the bottom for 0 is 3. For the top 2, 2 to the 4 plus 3 equals 19. So our boundary for the top now equals 19. Now this is one way to do it. There is another way to do it where we solve the integral and then we just plug back in our t's for our u's. But this is a nice looking integral, so it's going to be easier and more efficient to solve it this way. So this is going to equal 1/4, and we're going from 3 to 19. The integral of u to the 3 is u to the 4 over 4. And so now at this point we can just plug in our boundaries and figure out the area under this graph between 0 and 2. And so over here we've got 1/4 multiplying everything. Our first term, when we plug in 19, 19 to the 4 is 130,321. Of course, that's over 4, minus 3 to the 4 is 81 over 4. So, common denominator, we can go ahead and subtract the 81 away. And what we end up with is 130,240 over 4, all times 1/4. So we'll multiply that in, and we'll end up with 130,240 divided by 16, which comes out to be a nice even number of 8,140. And so that's our answer for part A. Now part B is very similar, and because it's actually the same substitution, it's actually like the same, everything's the same except the bounds. because of that, I'm just going to go ahead and let you work that one through and plug it in. You will have to change the bounds from t's to u's using our u sub formula to change the boundaries. But besides that, we've already taken the integral, so you'll just change the boundaries and use this form here. Alright, I hope this was helpful, and I'll see you next video.